Hello everyone, this is Bojun Liu, and I'll present our fast concurrency analysis framework D4 in this video. Consider the example in which the main thread creates a new thread. Both of them perform some read and write action on X and Y and Z. Now let's run the data race and deadlock detection in D4 for the whole program. As we can see, the bug view of D4 will show a list of detected races and deadlocks. Besides, the bug-related statements are also marked in the editor by the race and deadlock icons. When you double-click a bug, more detailed information will be provided, including the race variable, the concurrent access location, and the possible trace from program entry to the access. Taking the first race as an example, the race happens on variable X with a pair of concurrent read and write access. For the read of X, a possible trace starts from the thread creation and then the read of X inside the thread created. For the write access, the possible trace starts from the main method and then the write access of X inside the main method. When you double-click each item inside the trace, it will direct you to the corresponding statement in the program. Except for the basic bug list view, D4 also has a view to show the concurrent reads and writes on a same memory location. The variable that have concurrent accesses has been listed on the left-hand side of the view. By double-click on the X, we can see all its write access. By click one of the write access, its concurrent read and write operation on X will be shown on the right-hand side. To better assist the debugging process, D4 is triggered each time the code change has been saved by the users. Now let's introduce a common log to protect the access of X. And save the file. D4 runs in the background and updates the bug list. Since the race has been fixed, D4 removes the bugs of X from the list. Then we used another common log to protect the concurrent access of Y. And save the file. Now D4 finds out the race on Y has been fixed, but a new deadlock has been introduced into the program. The further information is shown in the deadlock view with the two pairs of nested logs and one possible traces for each pair of the nested logs. To fix the bug, we update the sequence of the nested logs here and save the file. And we can see there's no bugs in D4's bug list, which indicates that all the bugs has been fixed. Let's restore the example program to its initial state. As a static analysis tool, D4 can report false positives, especially for large programs. We provide two functions to help users reduce the inference from false positives. One is ignore the variable. If users think a variable Y is thread safe but D4 reports bugs on it, User can right-click the reported bugs or variables in the outline view. Select D4, ignore this variable, so that D4 will no longer consider this variable in its analysis and remove all its related bugs and concurrent actions. Afterwards, if Y is no longer thread safe, user can right-click the variable in the outline view, select D4 and consider this variable. So D4 will start to report bugs related to Y again. The other function, ignore the method, is designed for the same purpose. Users can go to outline view, right-click the function to select D4, ignore this method, or consider this method, in order to determine whether D4 should analyze all the information inside the method. Thank you for your time. Hope you have a good experience with D4.